Hi, I'm Emily, and today we will be discussing Down syndrome. We will cover what it is, its prevalence in Australia, some common traits and behaviours, the neuroscience of Down syndrome, current treatments, and future directions. Down syndrome is a genetic disorder characterised by the presence of a full or partial third copy of chromosome 21. This occurs in some or all of an individual's cells, and this triple copy is also called trisomy 21. Down syndrome is the most common chromosomal condition worldwide. It is estimated that there are between 13 and 15,000 people with Down syndrome in Australia, and approximately 290 babies born each year with Down syndrome. The onset of Down syndrome occurs during prenatal development. As the age of the mother increases, so does the chance of having a child with Down syndrome. According to Down Syndrome Australia, this increases from a 1 in 1,400 chance for a 20-year-old to a 1 in 30 chance for a 45-year-old. Down syndrome affects almost all body systems. Individuals born with Down syndrome have an increased risk of congenital heart disease, respiratory infections, leukemia, gastrointestinal, musculoskeletal, and autoimmune disorders. They also commonly experience hearing and visual problems, as well as difficulties with speech. The major feature of Down syndrome, however, is an intellectual disability, which will be the focus for this presentation. Individuals with Down syndrome experience deficits in short-term memory, which impairs their performance in different cognitive tasks, including language, vocabulary development, and problem solving. During adulthood, there is a further loss of cognitive abilities, with the development of Alzheimer's disease common after 40 years. There is also an increased frequency of anxiety, sleep disturbances, hyperactivity or movement disorders, and epileptic episodes. Volumetric MRI studies have shown that adults with Down syndrome have overall smaller brain volumes with disproportionately smaller cerebellar, hippocampal, brainstem, frontal and temporal lobe volumes, along with a widening of the sulci and narrow superior temporal gyrus. Specifically, the cerebellum has been shown to be important for cognition, verbal fluency, and language skills, while general intelligence is linked with the parahippocampal gyrus. There is an inverse relationship between its volume and IQ in individuals with Down syndrome. At the cellular level, the Down syndrome brain has changes in the structure and functioning of neurons, the cells that carry electrical impulses within the body's nervous system. They are composed of an axon and dendrites, which form neuronal circuits and enable transmission of electrical information. Dendritic spines help dendrites transmit these electrical signals. According to a study published earlier this year, in individuals with Down syndrome, there is a reduction of dendritic branching and spine density in neurons of the hippocampus and cerebral cortex, affecting neuronal connectivity in the brain. Neurotransmitters are chemicals that help transmit electrical signals between neurons. They are excitatory or inhibitory in nature, and the activity of the brain is regulated by the balance between these opposing systems. In Down syndrome, there is dysfunction and degeneration of several neurotransmitter-based systems, including a major inhibitory neurotransmitter called GABA. The impairment in GABAergic transmission leads to learning and memory deficits. Currently, there is no effective pharmacological treatment to help reverse the cognitive impairment seen in Down syndrome, although recent research has investigated the use of the GABA receptor as a potential therapeutic target and has had some success in a common mouse model for Down syndrome. Additionally, a study by Toomey et al. Has shown that physical activity may help to improve cognitive function and memory. Other treatments focus on strategies and therapies to help improve speech and articulation, physical therapy to help with motor coordination, a healthy diet, and early intervention programs. In the future, targeted treatments to reverse or prevent decline in cognitive function should be investigated, particularly looking at the disease in later life, where Alzheimer's disease is common. It should be noted that to date there is no perfect mouse model for Down syndrome, so new ones should be developed, along with parallel human and animal studies. Furthermore, new neuropsychological tests should be developed specifically for Down syndrome, rather than relying on IQ, which is known to vary significantly between individuals with Down syndrome. From a societal point of view, the focus moving forward should be on using appropriate language to describe the condition. In my research, I repeatedly came across the use of the R word to describe the intellectual disability, a term now considered highly offensive to individuals of the Down syndrome community. Along with this, the emphasis in future should be on the transition to employment, providing healthcare, financial, and legal support, as this is essential to the long-term well-being of individuals with Down syndrome and their families. To conclude, Down syndrome is the most common chromosomal condition worldwide, and it affects almost all body systems, with an intellectual impairment being a main feature. Of concern is the continued loss of cognitive abilities in adulthood and the high prevalence of Alzheimer's disease. So continued research to better understand the pathophysiology of Down syndrome and development of targeted treatments will be highly important in the future.